Okay, this video is solving trig equations, still section 6.5, and this is part 2. In this video, we'll talk about when they ask you to solve the equation, and those are kind of vague directions. Basically, what that means is find all real number solutions, which isn't that easy to do because a lot of these will have an infinite number of solutions. All right, so let's look at this one. Find where the sine of theta is equal to negative root 3 divided by 2. All right, now, first of all, just to mention this, when they say real number solutions, that means we are going to work in radians because radians are real numbers and degrees are not. All right, so let's figure out where does the sine of theta equal negative root 3 over 2 just between 0 and 2 pi, like we were doing in the last video. All right, so that will happen down near the bottom of the circle, here and here, at 4 pi over 3 and 5 pi over 3. All right, now these are just two answers. Let's focus on 4 pi over 3. All right, that's the angle that starting here would rotate in a positive direction that many radians. Okay, so that is certainly an answer for this question. Now, you could also say 4 pi over 3 plus 2 pi is an answer. Because if you rotated 4 pi over 3 and then rotated an additional full revolution, you would be at the same terminal place. And so this angle here will have the same sine value. All right, now we could go ahead and add this together and get common denominators and what have you. But just understand this angle is a different one than 4 pi over 3. It is coterminal with 4 pi over 3. So that would be another answer. Okay, now if we did another revolution around 4 pi over 3 plus, well, now I've added on two amounts of 2 pi, that's going to be a third answer. That's another coterminal angle. So I actually could keep doing this. 4 pi over 3 plus any amount of 2 pi where n is an integer. Now, integers can be negative, so this would include, say, -1. And so I'm saying that 4 pi over 3 minus 2 pi is also a solution, which it is. All right, that works out to be a negative angle. In this particular case, if you get common denominators or what have you, you'd be talking about negative 2 pi over 3, which is still with the same terminal side, but it rotates in a negative way. So basically, 4 pi over 3 plus any multiple of 2 pi is going to be a solution. They will all have the same terminal side. They all have the same sign that's equal to negative square root of 3 over 2. So what we usually write for this is 4 pi over 3 plus 2n pi. The n kind of sneaks in the middle there. It's a little bit easier to say. A lot of times people just assume that you know that n is nth integer. Your textbook says where, they actually write it out, n is any integer. Okay, so all of these are solutions. And then you can't forget about, we also have another angle with a different terminal side. That would be 5 pi over 3. So that angle also has a sine equal to negative root 3 over 2. And we want to include any angle that's coterminal with it. So we're also going to say 5 pi over 3 plus 2n pi, where n is any integer. So these describe all the real number solutions to the equation. Okay, let's try another one. This one says to solve the cosine of theta being equal to 1. All right, so if we think about where that would happen, the cosine of theta is equal to 1 at 0. if this is the terminal side, the point right here has an x-coordinate of equal to 1. All right, so theta could equal 0, all right? Plus, like we saw in the last example, plus any angle that is coterminal with it. So if I were to add 2 pi, I would continually come up with more angles that were coterminal. So I could say plus 2n pi, which that simplifies. So theta could be 2n pi, where n is any integer. N is any integer. Okay, now, some problems have a little bit of a twist to them. The tangent problems do. This one says solve where the tangent of theta is equal to -1. Okay, where is tangent equal to -1? Right in the middle of the second quadrant and right in the middle of the fourth quadrant. Okay, so what happens with tangent, and sometimes happens in other problems, is that the two spots on the unit circle, just between 0 and 2 pi, are actually pi units apart from each other. This one is 3 pi over 4. This one is 7 pi over 4. If I take 3 pi over 4 and add pi to it, that works out to be 7 pi over 4. If I take 7 pi over 4 and subtract pi, then that's 3 pi over 4. Right? If I take 7 pi over 4 and add pi, that is going to work out to be 11 pi over 4, which is coterminal with 3 pi over 4. So if I take 3 pi over 4 and I add pi, I'll get 7 pi over 4. If I take 7 pi over 4 and add pi, then I'll get 11 pi over 4, which is coterminal with 3 pi over 4. If I add another pi, 11 pi over 4, 11 pi over 4 plus pi, that works out to be 15 pi over 4, and that is coterminal with 7 pi over 4. So, what's going on here, since these are directly across the circle from each other, they are spaced apart by pi units. So, to find all the angles that are answers to this, I don't need to add on multiples of 2 pi. Adding on multiples of pi will do the trick. So, what I will do when I see that there's 2 places in the unit circle, but they're directly across from each other, is I won't try to use both of them. I'll only focus on the smaller one, which is 3 pi over 4. And I will say I can just add multiples of pi to that to get all the solutions. So for this one, we'll say theta is equal to 3 pi over 4 plus n pi. The ones where you have n pi, it's because they were directly across the circle from each other and they were pi units apart. Okay, one last one. Solving the sine of theta being equal to 0. Okay, so on the unit circle, sine is equal to 0 at 0 and also at pi. Okay, this is a situation like what we were just looking at in the last one, that the two locations on the unit circle are directly across the circle from each other. So basically they're spaced pi apart. So I can just use the smaller one, which is 0, and add multiples of pi to keep getting more answers. So for this one, I can say theta is equal to 0 plus n pi. That's going to be multiples of pi. So theta is equal to n pi. Right. Like I said, a lot of textbooks, that would just be the final answer. In our textbook, it'll say n pi, where n is any integer. And then that would be the final answer.